Picture this. Our galaxy has over 100 billion stars, and it's been around for roughly 10 billion years. That's an unfathomable amount of time and an absurd number of opportunities for life to emerge. So here's what keeps astronomers up at night. If intelligent life has even a fraction of a % chance of emerging around those stars, our galaxy should be absolutely teeming with civilizations. Some of them millions of years older than us. Some of them should have colonized half the galaxy by now. But when we look up, we see nothing. No signals, no visitors, just silence. And in 2025, we might have finally found the answer. The year was 1950. Physicist Enrico Fermi was having lunch with some colleagues at Los Alamos National Laboratory. They were casually discussing flying saucers and the probability of faster-than-light travel, as physicists do. Then Fermi suddenly interrupted the conversation with 4 words that would echo through the decades. "Where is everybody?" His colleagues knew exactly what he meant. Even if intelligent life was rare, even if interstellar travel was slow, even if civilizations mostly stayed home, the universe has had billions of years. Plenty of time for someone somewhere to spread across the galaxy. Plenty of time for us to have noticed, but we haven't, and that's the Fermi Paradox. Now you might think this is just a fun philosophical question, but here's the thing. In 2024, researchers surveyed scientists about this very question. Over 67% of them believe basic extraterrestrial life exists somewhere out there. 2/3 of scientists think intelligent aliens exist, yet we've found absolutely nothing. Zero evidence. That gap between what we expect and what we observe, that's not just interesting, it's terrifying, because it means something is filtering out civilizations, either before they reach our level or after, and we need to know which one it is. So let's talk about what's happened in just the last year, because the research coming out in 2024 and 2025 has been absolutely wild, and it's all pointing in one very uncomfortable direction. First up, the origin of life itself. In July 2025, physicist Robert Endres published something that made a lot of people in astrobiology very nervous. He built this incredibly detailed mathematical framework for how protocells, the earliest forms of life, could have formed on early Earth. And when he ran the numbers, the odds are astronomically almost impossibly low. Think about it like this. Life requires thousands of specific molecular arrangements to happen in just the right sequence. It's not just about having the right ingredients. You need the right ingredients, in the right place, at the right time, doing the right things. The complexity is staggering, and Endres's math suggests that spontaneous emergence of even the simplest life is so unlikely, it might be the great filter all on its own. But wait, it gets worse. Let's say life does manage to emerge. Great. Now it needs to evolve into something complex. Multicellular organisms, intelligence, civilization. In 2024, a team of researchers published a study about plate tectonics. Now, plate tectonics might sound boring, but stay with me. They found that Earth's transition into active plate tectonics directly triggered the Cambrian Explosion. That's the period 540 million years ago when complex life suddenly diversified like crazy. Here's the problem. Plate tectonics might be really, really rare. We don't see it on Venus. We don't see it on Mars. It requires a very specific set of planetary conditions that might not exist on most worlds. So now we've got 2 filters, the origin of life and the jump to complexity. But there's more. Manuel Scherf, an astrophysicist, did a calculation in 2025 that's absolutely mind-bending. He asked, if there was just one other civilization coexisting with us in the galaxy right now, how long would they need to have survived? The answer, at least 280,000 years. Think about that. We've had radio technology for about 130 years. We've had industrial civilization for maybe 250 years. We need to survive more than twice that long just to have even odds of there being one other civilization like us out there at the same time. 280,000 years of continuous technological civilization, without destroying ourselves, without stagnating, without going extinct. How many civilizations actually make it that long? Now let's talk about what we're actually finding when we search, or rather, what we're not finding. In 2024, astronomers pointed the FAST telescope, one of the most sensitive radio telescopes on Earth, at the TRAPPIST-1 system. This is a system with 7 Earth-sized planets. Some of them in the habitable zone, perfect place to look for signals, right? They observed for 1.67 hours, listened across multiple frequencies, searched for any kind of artificial transmission, but they found nothing, absolutely nothing. The VLA Sky Survey did something even more ambitious. They analysed over 950,000 observations of stars. They set detection limits between 10 trillion and 1 quadrillion watts for artificial radio transmissions. That's not some tiny CB radio, that's civilization-scale power we're talking about. Still nothing. The silence isn't just deafening, it's starting to look like a pattern. Every survey, every search, every new telescope, they all come back empty. And that's forcing us to confront some very uncomfortable possibilities. Alright, so maybe we've been too optimistic about how common Earth-like planets actually are. In 2024, researchers published something that honestly shocked a lot of people in the exoplanet community. They calculated how many planets in the Milky Way could actually have Earth-like atmospheres. Not just any atmosphere, but specifically nitrogen-oxygen atmospheres like ours. That number is between 60,000 and 250,000 planets. Now, that might sound like a lot, but remember, there are 100 billion stars in our galaxy. This means that Earth-like atmospheric conditions might exist on only 1 in a million planets, maybe 1 in 2 million. We thought habitable worlds would be common. Turns out they might be breathtakingly rare. And here's why. Most exoplanets we've found orbit M dwarfs. These are small, cool red stars that make up about 75% of all stars in the galaxy. Sounds promising, right? Lots of planets around the most common type of star. Except M dwarfs are terrible hosts for life. They're prone to massive flares that strip away planetary atmospheres. Their habitable zones are so close to the star that planets get tidally locked, one side always facing the star, the other always dark, and they emit tons of high-energy radiation. JWST observations of the TRAPPIST-1 planets have confirmed exactly this. Those planets that looked so promising, they don't appear to have any detectable atmospheres at all. The star's radiation likely stripped them away billions of years ago. But even if you find a planet around a nice, stable, sun-like star, there's another problem: the helium trap. Researchers discovered that if Earth had formed just 4 million years earlier in the solar system's history, it would still have a dense helium atmosphere today. That's because the early solar system was filled with hydrogen and helium from the solar nebula. Form too early and your planet gets smothered in gas it can never shed. Form too late and you might not get enough volatiles to create oceans. The timing has to be perfect. The star type has to be right. The planet's mass has to be just so. The distance has to work. You need plate tectonics. You need a large moon for stability. You need a Jupiter-sized planet in the outer system to clear out asteroids. Every single one of these factors eliminates the vast majority of planets. Maybe Earth isn't just rare. Maybe Earth is borderline miraculous. So, if life is rare, and if we haven't found anyone else, there's this concept we need to talk about. It's called the Great Filter, and it's probably the most important idea in the Fermi Paradox discussion. The great filter is whatever barrier prevents life from evolving into long-lasting, galaxy-spanning civilizations. It's the reason we don't see the universe full of aliens. Something is filtering them out. The question is, where is that filter? Is it behind us or ahead of us? If the filter is behind us, we're the lucky ones. We're the anomaly. We beat incredible odds, and now the galaxy is ours to explore. Uncomfortable in its own way, knowing we're alone, but at least our future is bright. But what if the filter isn't behind us? What if it's ahead? This is where things get dark, because there are a lot of ways a technological civilization can destroy itself, and we're facing most of them right now. Nuclear war, climate change, bioengineered pandemics, resource depletion. And here's a new one that's gained serious traction in 2024 and 2025, artificial intelligence. Some researchers are now arguing that AI might be the great filter. Think about it. Every technological civilization will eventually develop artificial intelligence. It's basically inevitable if you're progressing in computer science. But creating something smarter than yourself, that's dangerous. Maybe most civilizations create AI, and their AI either destroys them or it decides biological life is inefficient and replaces them entirely. Either way, the civilization as we'd recognize it will be gone. Then there's something called the asymptotic burnout theory. This one's sneaky. The idea is that civilizations don't necessarily destroy themselves violently. They just stop growing. They hit technological limits. They run out of easily accessible resources. They achieve a comfortable equilibrium and then stay there, quiet and undetectable, for thousands of years. No galaxy-spanning empire, no megastructures, just a civilization that learns to live sustainably within its means and never bothers expanding outward. Which honestly might be the smart play, but it would explain the silence. Despite all the null results, despite the discouraging math, despite the filters and the silence, the search continues. And honestly, the tools we're developing are incredible. In 2024, Breakthrough Listen partnered with NVIDIA to develop new AI detection systems for analyzing radio telescope data. These systems are 600 times faster than previous methods. That means we can search more stars, analyze more data, and spot fainter signals than ever before. In 2025, astronomers even searched for artificial objects hitching rides on interstellar visitors like Oumuamua and the object designated 3I Atlas. The idea being that if you want to explore the galaxy cheaply, you attach probes to comets and asteroids that naturally travel between stars. Smart, right? They found nothing. But the fact that we're looking, that's progress. Looking ahead, NASA is developing something called the Habitable Worlds Observatory. This telescope will be able to directly image rocky exoplanets around nearby stars. Not just detect them indirectly, but actually photograph them, analyze their atmospheres in detail, look for biosignatures. Europe is working on a similar mission called LIFE. Between these two projects, we'll have the ability to study potentially habitable worlds like never before. And here's something encouraging. In 2024, NASA established the Technosignatures Science Advisory Group. Their job is to integrate the search for extraterrestrial intelligence into mainstream astronomy. For decades, SETI was considered fringe science. Now, it's becoming part of normal astronomical practice. Every major telescope survey now includes searches for anomalous signals. Every exoplanet characterization looks for unusual atmospheric chemistry. The search for life has gone from a niche hobby to a core scientific priority. And every search, even when it comes up empty, teaches us something. So after all that research, all those surveys, all those calculations, have we solved the Fermi Paradox? Not exactly, but we're getting close to an answer. And honestly, It's not the answer we were hoping for. The origin of life is harder than we thought. The evolution of complexity requires unlikely planetary conditions. Breathable atmospheres are rarer than we imagined, and surviving long enough to become detectable requires making it through filters we're only beginning to understand. There might be only a handful of civilizations in the entire Milky Way at any given time. Maybe we're one of 3, maybe one of 10, maybe we're the only one right now. That's a lonely thought, but it's also a profound one, because if we're rare, that means Earth is more precious than we ever imagined. This little blue world, with its oxygen atmosphere and its plate tectonics and its absurd evolutionary history, might be the only place in the galaxy where anything like human civilization exists. That makes every species we drive extinct more tragic, every ecosystem we destroy more irreplaceable, every threat to our long-term survival more urgent. We might be the galaxy's only voice, its only witness, its only consciousness capable of understanding itself. If you found this deep dive into the Fermi Paradox fascinating, hit that like button and subscribe for more space content. Drop a comment below with your theory.